All right, this is Mr. Long, and I'm going to talk about empirical and molecular formulas. Now, I have this practice sheet here, and I intend to upload it after I present this. And there are a few problems on here, and if I don't get it uploaded, you got it right here. And we got a backside to this. And I'm going to say that this really isn't that easy. So I'm going to show you how to do the two hard ones, and then we will go from there. So number 5 on this. Now the empirical formula is the simplest whole number ratio. And number 5 states, determine the empirical and molecular formula of a compound composed of 8.24 grams of carbon, 0.51 grams of hydrogen, and 16.91 grams of fluorine, and it has a molar mass of 562.0 grams per mole. Well, first thing we're going to do is assume a 100 gram sample. So what we do is we write our grams out here, but in this one particular problem we did not have to assume the grams, or the percent is equal to grams. We didn't have to assume a 100 gram sample because it was already given to us in grams. So we wrote down the grams here from the problem, and we know it has a molar mass of 562.0 grams per mole. So what we do is we take the 18.24 grams of carbon, and this is a one-step stoichiometry problem from mass A to moles A. So you're going to use the periodic table, so 12.01. Now on this stuff you need to round to the hundredth because there are some little tricks in here and you have to be very exact. And this is going to be equal to 1 mole of carbon. And of course your grams of carbon will cancel out. Pull your numbers over, and then we get this divided by that. Okay, and well, actually first we get 1.52 first, so don't write anything else down. Now on the next part we're going to do this, and I'm going to bring over a blank sheet so I can follow to do a better job of doing this. And we're going to actually calculate the moles of each particular element here. So on this next one we have grams of hydrogen. So what we're doing is we're calculating, you get 0.51 grams of hydrogen, and you're doing the one-step stoichiometry. So we get 1.01 from the periodic table is equal to 1 mole. Pull your numbers over like this, okay, and we're going to get this of 0.5. So don't look at these numbers or this number yet. So we get 0.5. Then on the next one we got 16.91 grams of fluorine divided by the molar mass, 19.0, and pull the numbers over, and we're going to get 0.89. Now, what we then do, we want to divide by our smallest mole. So the smallest mole that we have here is 0.50. So we divide that by 0.50, that equals to 1. And we divide 0.50 into 1.52, that equals to 3. And then we're having the 0.89 divided by 0.50, that equals to 1.78. And the empirical formula is the lowest whole number ratio. So this is a nice whole number. This one is a nice whole number. But this is not. And this is very close to 1.75. So sometimes you just have to round to somewhere, whether it's 0.25 or 0.5, 0.75 or 0.33 or 0.66 or 0.20 or whatever. You get around it to something that you can multiply by. So this is rounded to 1.75. And to make a whole number, you're going to multiply this by 4. So, because 4 times 0.75 is going to be 3. And 4 times 1 is 4. So this comes out to 7. And so we've got to multiply these other numbers by 4. So 1 times 4 is 4. And 3 times 4 is 12. So the 12, the 4, and the 7 are going to be our numbers for the empirical formula. Now, we do want to keep the most electronegative element for last, so that's going to be fluorine. And carbon and hydrogen will be in front in that order. So what we've done here, we have this, and so we put carbon 12 here, so this 12 will come over here. This 4 come over here by hydrogen, and fluorine gets this 7 right here. So this is the lowest whole number ratio, and so that is our empirical formula. Now next it gives you a molecular formula, and the molecular formula of this one is 562.0. So what we have to do is we have to do the molar mass of this compound. You get it from the periodic table, and you add it up, and you get 281. I didn't round to the hundredth here because we already have our empirical formula, and that's our molar mass of this compound. And what we have here, we were given 562.0 as our molar mass of our compound. So we want to know what is the molecular formula. So we divide 281 into 562 and we get 2. So that means we can multiply by 2 all this that's in our empirical formula. So we're going to multiply by 2. We've got 2 times 12 is going to be 24. 2 times 4 is going to be 8. 2 times 7 is going to be 14. So this is our molecular formula, what the actual formula is. And this is the one that we can reduce it to, the empirical formula. So the trick, so what we do, we calculate our moles for each element. Okay, that's easy. And then we're going to divide by the smallest mole. Find which one is the smallest and divide into all the moles. And then we get our numbers. And if you get one that's not a nice even number, well then you've got to do something with it. So 1.78 was very close to 1.75. We had to multiply by 4 to get a whole number here. And that came out by 7. And we multiplied by 4 by these other two numbers of moles. That was our empirical formula. And because we have a molecular formula, we're asked, is this the molecular formula? Or what is the molecular formula? So we've got to get our empirical, our molar mass of our empirical formula and divide it into our molecular formula, and it was 2. So you multiply everything by 2. This was number 5. So that wasn't the easiest problem. I think mainly because of this right here. Now let's go on to number 7. So on this, because I've already got it written out, you got to stop, pause, rewind, stop, pause, rewind to take proper notes. So I just got through going over this in my 4th period today, and so it was already conveniently written down. Now, number 7. Okay, let's look at number 7 for a second. Here, we've got the percent composition of an unknown substance is 75.42% carbon, this percent of hydrogen, this percent of nitrogen, this percent of oxygen. It has its molar mass of this, 334.0. What is the empirical and molecular formula? Well, we got a lot of moles to calculate. Four different moles for different elements. So let's do that first. So we're assuming a 100-gram sample, so we can turn the percents into grams. So on number 7, so we have that, and we are going to calculate our moles. So we do this for carbon, and we're going to get this 6.29. Pretend, oh, I've got to focus this, huh? Let's try it again. Okay, there it goes. So we get 6.229, and don't write anything else down yet. We'll come back to this. Okay, and you do the same thing for hydrogen. So we do the same thing. You go to the periodic table. One step stoichiometry problem. Pull your numbers over. And we get 6.6. You don't see that number yet. And then we've got to do the same thing for nitrogen. You got this many grams of nitrogen divided by the molar mass of just N, not N2, just N, because we're going by percent composition and empirical formulas. We're not doing the diatomic. Okay, so you do this, you pull your numbers over, and we get 0.60. Well, that's good because we already got one. And then lastly, we got the big O, oxygen. And so we have 95.7 grams of O divided by this from the periodic table equal to 1 mole. And so we pull the numbers over, and we're going to get that. Okay. So now what do we have to do? We divide now by the smallest mole. So 0.6 is smaller than 6.6 and it's smaller than 6.29. Okay, and it's the same as 0.6 here. So you divide by 0.60 on all of these. So on these two guys, we get 1. For this, we get 1 for oxygen. Over here, 0.6 into 6.6, we get 11. And then for here, 6.29 divided by 0.6 is 10.5. Well, I'm glad it was 10.5 because you can multiply by 2 to get 0.5 to a whole number. So this times 2 is equal to 21. And what we multiply by 1, we've got to do them all that way. 11 times 2 is 22. 1 times 2 is 2. And 1 times 2 is 2. Okay. Now, because oxygen is the most electronegative many times of elements, it's going to be last. And when you combine with carbon and hydrogen and nitrogen, carbon and hydrogen go first. Okay? So we're going to be saying C21, and here's the 21 out here, H22 into O2. Now, if you happen to put O2 then N2, in my book, that's still okay, because you didn't know how to differentiate between the negativities of these, and it might even be O2 than N2. So this was our empirical formula. So now, to figure out what the molecular mass is, we got to calculate your molar mass. So, or your molecular formula. So we do 12.0 times 21 for the carbons, and then 1.0 times 21 for hydrogens. I'm sorry, not 21, but it was 22. Okay, and then 14.0 times 2, 16.0 times 2. You add this up, it's 334 grams per mole for our empirical formula. And our molecular mass that we were given is 334.0. So that happens to be the same. So, because it's not a multiple, our empirical formula is our molecular formula. They are one and the same. So both of them are C21, H22, N2, and O2. Okay, so I'm going to stop here, and then I'll work on uploading this. So I'll see you guys on the next lesson.